Hello viewers, this is KULKARNI again with my new video, Properties of Midpoint Theorem for Triangles and Quadrilaterals. Today we will see the properties of Midpoint Theorem for an activity. Pratiksha Jadhav of class 9 standard will explain us regarding the activity she has prepared for the Midpoint Theorem. Pratiksha, please come forward and explain the activity.
D is midpoint of AC, E is midpoint of AB, F is midpoint. Triangle obtained by midpoint is EDF. And this is congruent to all triangles.
You can see here, this is the triangle ABC. The midpoint of AB is D, the midpoint of CD is F, and the midpoint of AB is E. Now, when you draw a triangle, by joining these midpoints, you will get another triangle, that is DEF. Now, if I remove this triangle, if I remove this triangle DEF, you can see that the triangle obtained by joining the midpoints of the three sides of a triangle is congruent to the remaining triangles. You can keep it over them and you can verify it yourself. So now you can see this is the original triangle and these are the remaining triangles. Now the triangle is congruent to the three triangles that we are getting over here. So this is the first property that we have. So now Pratiksha, second property.
When we cut quadrilaterals midpoints, here E is midpoint of PQ, G is midpoint of QA, H is midpoint of SR, and here we obtain rhombus.
Now what she wants to say is PQRS is the rectangle and E is the midpoint of PQ, then F is the midpoint of this one, H is the midpoint of this one, and HG is the midpoint of this point QR. When we join the midpoints here, we are going to get a quadrilateral. So this quadrilateral that we get over here, is a rhombus. So what I mean to say here is, the quadrilateral obtained by joining the midpoints of a rectangle is always a rhombus. So this is the property theorem. Our students, Aisha, Nandini, Bhumi, Shruti, these students will explain the properties of midpoints of a quadrilateral. What happens when we find out the midpoints of different quadrilaterals? What shape we get? Let us see.
ABCD is a trapezium in which PQRS are midpoints of side AD, BC, BC and CD. When we cut the midpoints of a trapezium ABCD, we get a new shape which is parallelogram having equal and opposite sides. PQRS is a parallelogram which having equal and opposite parallel sides.
Here, what Aisha wants to say is, you can see here A, B, C, D clearly it's a trapezium. Q is the midpoint of AB, R is the midpoint of BC, S is the midpoint of BC, and P is the midpoint of AD. Now, when you join these midpoints, you are going to get a quadrilateral, and the shape of that quadrilateral is a rhombus. That means the quadrilateral obtained by joining the midpoints of a trapezium is always a parallelogram. So this property, actually you can prove it through midpoint theorem also. We are doing it here with the help of this activity. I repeat again, the quadrilateral obtained by joining the midpoints of the trapezium is always a parallelogram. Okay, Nandini, which one you are going to explain?
Get a new shape which has equal sides. It's rhombus.
It's a rhombus. here. See, what we want to say is EFHG is a square, and the midpoint of the side EF is T, the midpoint of side FH is U, and GH is V, as well EH is T. Now when you cut the midpoints of this, when you join the midpoints of this, you are going to get another quadrilateral, and the quadrilateral obtained is the quadrilateral obtained here is, this is the shape of a rhombus. So this is what we can study through this activity. Now who is going to explain the third one? Come here, this side. Yes, please. Now click this.
In a quadrilateral VUTS, which is rhombus, we get midpoints. We cut of the side SV, VU, UT, and TS. We can see here SV, TSV's midpoint is L, VU's midpoint is M, UT's midpoint is N, and ST's midpoint is O. When we cut the midpoints of all sides, we get another quadrilateral. We can see here it's square.
Only what she wants to explain here is, she has taken a rhombus. The name of that rhombus is VUTS. She has marked L as the midpoint of TS, M as the midpoint of VU, N as the midpoint of UT, and ST midpoint is O. Now when she is joining the midpoints, what she is going to get here is, she is going to get a square here. So what we can conclude from this activity is, the quadrilateral obtained by joining the trapezium, this is a rhombus, sorry, it's a parallelogram. The quadrilateral obtained by joining the midpoints of a trapezium is a parallelogram. The quadrilateral obtained by joining the midpoints of a square is a rhombus. The quadrilateral obtained by joining the midpoints of a rhombus is a square. So we can prove this one with the help of a midpoint theorem also, theoretically also. This is the practical proof of it. Through a toy, we are trying to prove it. We are trying to prove the properties, the midpoint theorem properties, with the help of this toy. My students Prachi and Ishwari will tell us what will happen if we find a quadrilateral by joining the midpoints of a parallelogram as well as a kite. So now I request Prachi to explain the things.
ABCD is parallelogram in which N, O, PM are midpoints of sides AB, BC, CD and DA respectively. When we cut the midpoints, we got a figure, another kite, EFGH and EFGH. When we cut the midpoint, P is the midpoint of H, P is the midpoint of H and E, Q is the midpoint of E and F, R is the midpoint of F and G, H is the midpoint of S is the midpoint of H and G. When we join this midpoint, we got a rectangle PQRS.
I'll just explain just now. See here, ABCD is a parallelogram. M is the midpoint of AD, N is the midpoint of AB, O is the midpoint of BC, and P is the midpoint of CD. When we join the midpoints of this parallelogram, the resulting quadrilateral that we are going to get here is again a parallelogram. Another position. So the resulting parallelogram, the resulting quadrilateral that we are going to get is this again a parallelogram. So that means what? The quadrilateral obtained by joining the midpoints of sides of a parallelogram is again a parallelogram. In the second figure, you can see here EFGH is a kite, P is the midpoint of EH, Q is the midpoint of EF, R is the midpoint of G, and S is the midpoint of HG. Now once again, when we join the midpoints, this one, the resulting figure that we are going to get here is rectangle. So what we can conclude is the quadrilateral obtained by joining the midpoints of a is always a rectangle. So this is an activity to prove the following concept.